the electricity is generated through generator. So that the generator requires the mechanical energy, and then only you can get the electricity. But this facility is with solar energy, so that without converting mechanical energy, you can convert electricity from the basic form of the source, that is the solar energy. So here, that means I will try to connect that what is the importance of solar energy in fuel. So there, basically, we broadly we can classify the fuel into two categories: that is fossil fuel and the biofuel. And you can say that this is the well-known definition of the fossil fuels, which is in the form of the oil, coal, or gas, and it has the limited sources. So that's why, and I can say that that is also derived from the sun only, solar energy only, but it took a long time for that. But this biofuel, again, this biofuel can be defined as that. I think this is not the new thing I'm telling you. I'm not defining this biofuel from my own, but I want to connect so that you will have the interest that how this solar energy is connected with the biofuel or the fuel in particular. So a biofuel is a fuel that is produced through, let us read this definition, through a contemporary process from biomass. Yes, that is there. That means a biofuel will be produced, can be produced by introducing some process, by following some process, and from where? From biomass. So that is the thing. So the biomass is the source, and from biomass we can have the biofuel. And for that we need some process, and for processing we need some device. And those device will not work until unless you have to give some input, that in the form of some energy. So that energy can be obtained from the solar energy. So that's where we can introduce this. That I think this is the way. And another thing, that if the process require thermal energy, heat energy, so that directly we can get from solar energy. And if the some process to produce the biofuel from biomass, that also can be obtained from solar energy directly in the form of the electricity. So that means that is the things why I'm discussing this, at least under introductory, so that it's the two things, that means the solar energy and biofuel or the fuel should not be separated out. If they are, I think, how my basic objective to discuss that I'm just discussing the importance of solar energy in your area, in this area, this in the fuels and biofuel. So the process of manufacturing biofuel is done in various stages. I think that is there because ultimately it is the biofuel is obtained from biomass. Required special device which need energy. This I already told, and that energy form which is required, that could be thermal energy or electrical energy, and that can be provided by this. I can say from the solar energy. So now I can start the actual solar energy, and initially I'll discuss some basic thing with the solar energy, and then slightly some application of we can have. So again, we it's always there. I think I used to tell in every lecture, that means whenever you want to deal some, if you are engineer, so your main concern is to design, to devise the system. The system is which converts the available form of energy into useful form of energy. That means the suppose some source is there, so I cannot create the source. Source is available, especially these renewable energy sources. They are naturally created. I cannot create it. But if I can use these resources, the form of resources directly to fulfill my need is okay. But if I need to convert this into useful form of energy to fulfill my this need, then engineer's job is there now, that to design the conversion system. So that system is to be designed by the engineer, and this the system should be what is the criteria? What should be the points which we have considered initially to design the system? It should be efficient, it should be cost effective, and it should be reliable. So that means at least these are the minimum points I'm talking about. That means uh, for engineer, I'm recommending that at least these 3 points a designer should keep in his mind, because if you are thinking to have a very high this highly efficient system, and it is not reliable, then there's no use there. And if it is very costly, that means people cannot afford that. I can say that this I don't want that high efficiency. So that means all the 3 points you have to optimize. So then I consider that you are a good designer. So next Uh, this is then I'm telling you that this basically uh, India. I'm talking about India. That we are lucky enough because we are on the Earth's surface in that location where the intensity of solar radiation is maximum. That maximum range is 300 watt per meter square. If you average over a 24 hours in a day, so that means this India is just talking about this 250 or so. So that means this 300 is in a very small region, but next to 250 we are having. So we are in this. So we are lucky. That means as far as the potential concerned, we don't have the problem of solar energy. This is I'm talking about the solar energy which is directly available to me. As far as the indirect application of the solar energy, then I think we know that that means all the this I can show you that uh, why this we can say that why we pray this हम सूरज भगवान को क्यों पूजा करते हैं? Because it is the prime source of all the energy. That in this case you can see that the solar energy coming to Earth's surface, and it is utilized indirectly by growing the tree. That we call this a biomass, because biomass. So that means if you talk about the biofuel, the source is biomass, but this biomass derived from where? It is again this. It is derived from the sun. If there's no sunshine, then that means it will not grow. So biomass will not be there. Then if you talk of the hydropower, so hydropower is due to the hydro cycle. You know that this hydro cycle, and because of from then the water vapors condense on the hilltops, and then it will flow. So that means that potential energy is used to develop the hydropower. So that is also derived from the on the other case, that is wind also. Wind also is generated due to uneven temperature of Earth's surface and water. And this temperature, how this uneven temperature is due to the sunshine or the solar radiation or the sun energy or solar radiation or solar energy. So that means, and if some amount which is coming entering in the space or the atmosphere, but that may that may reflect it back. So that means I can say that even this also the role of the solar energy. But now, if you are talking about today, we are talking about that the amount of solar radiations which are reaching to us in the form of the sun energy, that is around 47%. So that 47% it is available in the form of the radiation, and our concern is to tap that. How we can tap that? Based on our applications, the need, and the through system. So again, that means this is, you can see that it means the on an average we have the solar radiation. I think this value, you please I'm trying to explain you what is this. This 4 to 7 kilowatt hour per meter square per day. So it is there. That means you know that the solar energy is varying with time. So that means how this average is taken. So I think it is taken like this. That means every day in a particular month, we measure the solar radiation every hour, take the average each hour from 6 a.m. to say 6 p.m. or sunset to sunshine. So that means every hour, this average, I think the solar energy watt per meter square, I'll discuss that also. So that means please remember this. That means if somebody says that what is the potential of what is the potential of solar energy in India? So it is very difficult to give the value because it depends upon the how much surface area you can provide to tap the solar energy. So that means, but in the form of the solar radiations, the average solar radiation we can estimate. So that means it is what is the meaning of this 4 to 7 kilowatt hour per meter square? That means if you have a surface area in India, I'm talking about. So that means the solar energy, that's 4 to 7 unit, 4 to 7 kilowatt hour means a unit in the form of the electricity I'm talking about. Uh, if you have 1 square meter, so in a day, these units you can receive in the form of the solar radiation. So that is the thing. Then after that, you have to devise, you have to design the system so that this how much this available energy you can convert, that will depend upon your system. Of course, the efficiency of this conversion efficiency is poor in comparison of other systems, of course, but still it is available there. So in Rajasthan we have maximum, and on an average we can say that about 250 to 300 out of 365 we have the sunshine in India I'm talking about. So that means as far as the solar radiation concerned, we don't have any problem. So we have substantial amount of solar energy. Only thing we want to tap it with the and nowadays. I think this 15 years or 10 years back, there was a problem with the unit generation cost. We could not brought this below 20 rupees per unit, but now it is good. It has gone down, say even uh, 2 to 3 rupees per unit. So that means there is no problem. So because 1.5 hours is not sufficient for me to cover everything. So I'm telling you that means when our because what let me tell you what we are doing. What we are doing. Suppose you are working in the area of fuel. Okay, fuel can be of biofuel. Okay, you want to you have to produce this fuel. This is your requirement, and suppose this requirement this process is required for that. So that process you can have any process you can say. Suppose you want to generate the this, this uh, gasifier system is there. So you want to generate the gas. So that means you need gasifier, that I call the system, or any process device will be the system I call this, which will convert the available form of energy. That means biomass. Suppose you have the biomass. Okay. So what I have to do, that means to convert this biomass into fuel, you need some energy. That source of energy you need. Even what you are creating the source of energy. But I think there's a advantage, disadvantage. I don't say that means, and so that what you have to do. So that means you need some energy to drive the system. So here, this biomass and the system I'm considering the system because this is your requirement. But my objective is that how much energy from sun I can get you. I can supply to you so that you can get the from biomass to this biogas or whatever this fuel you want. So in that case, I have to devise some system of solar energy which will give the energy to your process. So that means in order to just estimate, means you have to estimate that how much energy. Let me give the example here. Suppose I'll have one example of this turpentine oil making process through this fine resin. It needs thermal energy. It needs, and then thermal energy can be obtained from the solar energy. So that means how much energy I need, I should estimate that. So that means for that, there's that you should understand that in what way solar energy reaching to Earth surface. So I tell you that means from sun to earth, solar energy is distributed like this, that I can say that a part of the solar energy in the form of the solar radiation is absorbed in the atmosphere. Some will be directly coming to you, and some you will get after diffusion, because the solar radiations may strike over the dust particle or the water vapors which is in the atmosphere, that will be there, and some will go back. So that means I'm interested in this only because this is available. So this is beam radiation and diffuse radiation. So these components should be measured separately. It is okay. I think this way I should discuss, or I have changed my style.
No, no, sir. It's okay, sir. Please continue.
Okay, yes, please, because if you don't have interest, then I can change my direction to otherwise. Okay,
That's okay, sir. Please continue.
okay. Thank you. So that means again, I'm telling you that the source, no problem, it is available. Uh, there's no problem of availability, but other thing also is very simple in this thing. That means measurement. If you want to estimate the potential of hydro or wind, so that means there's a tedious task over there to measure. Even the instrument is complicated, but in solar energy, a very simple instrument is there. That means there is a sensor. So I'm not going to discuss that sensor, that whatever solar radiations are falling on this, and it is directly calibrated in terms of the power, that is watt per meter square. So that is again another beauty with the solar energy. That means whatever parameter you measure, that is known as the solar radiations. So solar radiations, that also that itself give the power. Otherwise, there's no need to convert this in unit. It is what is power. So that means it's directly available to us. Then let me tell you that what could be the maximum value of solar energy we can have. So that is defined by the maximum. I just write that is defined by the solar constant. So I think this is very important to to, to remember this in the field of the solar energy radiations. I'm particularly the solar constant. Solar constant is the maximum possible value which we can get from the solar radiation. So that is the 1353 watt per meter square. And what is this? That means if you have sun over here and I have the earth surface here and around the atmosphere is there. So that means this is space, and this is atmosphere, and this is earth surface. So that means I'm interested that what solar energy is reaching to me up to this. So I can say that in space there is no problem. The intensity of solar radiation will not vary because it's a neat. That means there is no foreign elements in there. The problem in the atmosphere when it enters, so that I don't know how much it will get, because some part will be absorbed and some part will be reflected back, and some part again from the surface. And the only thing, as I told you, that the diffuse radiation and beam radiation I will get. So that means if I estimate, it is estimated that how much solar radiations just outside the before entering the atmosphere. So that means that can I put the limit, that means that is the maximum possible value can be, that if I say that if the this condition of the atmosphere, that I'm just assuming ideally that if there's no clouds, there's no dust, this atmosphere is so clean that it looks like a space, it appears like a space, then I can say that whatever solar radiations will be here, the same amount will be here. But that's why this limit is represented by solar constant. It is measured just outside the atmosphere, and when the solar radiation is falling on the on the receiving surface at 90 degree, at perpendicularly, then only I can get them. So that means this is known as the solar constant. You will have the notes with you. So that means you can read the definition or you can understand. The only things, so its value is this. So out of this we can get, and it depends upon that out of this how much you will get, but that depends upon the atmospheric condition. Because a part will be absorbed, a part will be reflected, a part will be directly coming to me in the form of the beam, a part will be diffused. So that means uh, if there's a clouds, total clouds are there, means that means sunshine is not there. So even then solar radiation will be reaching to you. So those solar radiation will be known as the diffuse solar radiation, diffuse, diffuse solar radiation. And if the sky is clear, atmosphere is clear, like in hills in summer when the sunshine is very sharp, this bright, then I can say the maximum solar radiation will be coming in the beam radiation or direct. So that means this is I'm not going to cover because it's not possible. So I think whenever you want to estimate the solar energy, so that means you have to estimate the beam radiation and diffuse radiation separately. Why I'm talking about, because the total solar radiation, this total solar radiation is beam radiation plus diffuse radiation. So I'm interested in this, but sometimes some system I think we can define the device which convert the solar radiation into thermal energy or uh, electricity. So that means some device they only consider the beam radiation. They don't consider, don't take the diffuse radiation. In that case, I'm not interested in H. I'll be interested in beam radiation only. So that means uh, we have to measure these two components separately. So it is very, I'll discuss after that. It is very easy that, as I told you, that how you can, because when you put the, suppose outside or under sunshine, if I put the sensor, so that means solar radiation will fall on this and it will measure, and that will be the total solar radiation, because diffuse radiation also falling on the sensor and beam radiation also. But I want that to know that separate uh, component of the solar radiation, beam and diffuse separately. So it is very simple mechanism. So what is there, that I have two sensors installed at one location. So what is there? That means I will uh, put one sensor which is the same similar under a shadowing means it will cover the sensor so that the direct solar radiation should not fall. That means it will be under shadow only. So that means a solid ring, that means we call this shadow ring, just over this bulb. So what is there that time, this sensor, it is uncovered, so it will measure the total solar radiation, because diffuse and direct also falling on that, so it will give the reading of the total solar radiation. But for this sensor at that same location at the same time, you have protected to fall the beam radiation over this sensor. So in that case, the reading of this recorder will be diffuse solar radiation. So now if I want to know the beam radiation, so from this reading, whatever radiation's values, suppose it gives 900 watt per meter square, and its reading is say 200 watt per meter square. So what will be the value of the beam radiation? It will be 700 watt per meter square. So that means this is very simple. So this is the things, okay, they measure, but the problem is that because solar radiation is varying every second, every time, every different at different locations. So it is very difficult to handle the solar radiation. So the simple, they take the average. How they take the average? Suppose at Roorkee, at my place, I want to. I'm not doing good. I'm not doing this exercise. This exercise is being carried out by some dedicated organizations. We call this in this simply weather monitoring station. They are doing this job. They are continuously monitoring, they are continuously measuring the solar radiations, and then take the average, and then they put on the this on the website, or they just publish the book. So from those books we use those solar radiations. So suppose today I want to use to design my system, I want to use some solar radiation, it is available to me. It is available to me. So that means in what form it will be available. So that means I am telling you that what they do for a particular day, they just measure every second, every minute, or a hour, say from 6 to 7 a.m. So they take the average. So that means one value will be watt per meter square for a particular time. Say I put the 6 o'clock. From 7 to 8, again, they take the average that will correspond to 8 a.m. So like whole day they will do in a particular day. And throughout the month, say January 1st, January 2nd, January 4th, all the 31 days, they measure like this. Then uh, again, it will be so many values. So they take the further, they have the average. What average they take? They feel that at 7 o'clock, hourly solar radiations at a particular location almost will be same. There will not be, I'm talking about the normal conditions. It's not like that if today is cloud and it will be the same solar radiation. So that means they take this average for all the 31 days at particular time. So now the and throughout the month. So that means how many values in the month of January you will have? Only 10 values or 12 values every hours in a day. Similarly, in February, March, April, like this. So I think if I want to this disturb तो नहीं हो रहा बेटा?
Right. ठीक है, continue.
No, I'm actually another other class is going on in my room. Sorry. So I'm asking. So this is the things I'm talking about. That means at 6 o'clock in the month of January, and this is not the for a January 1st. It is average throughout the month at 6 o'clock. Similarly, at 7 o'clock, this is the average for average of what? Every day in the month of January, you have measured the solar radiation at 7 o'clock. So it is the average of that 31 values. It is the average of 31 values because we know that there is too much variation with respect to hours. So that is the thing. So every month we have only one value that is taken as average, one value for a particular time. So this table is available to me. Suppose I can say that a location or the place is represented by latitude. So that means if you have two different places and having same latitude, so same latitude, so I recommend that you can use, uh, uh, no doubt that that will be too far away from you, but it is better that you use the solar radiation for nearby latitude only, not nearby place only. So that's why this table will be applicable for the locations which have a particular latitude. So in that case, please just because this value, I'm in hurry. I cannot. I'm not happy. I'm not satisfied that I could explain you properly. I'm explaining properly, but still you have some idea. So that means finally, when I want to design the system, I'll be interested in this. That means at that location, if somebody asks you that at Roorkee in the month of January, how much energy or solar radiations will be there at any day in the month of January. So you can say, okay, it is 4.15 kilowatt hour. That is the energy I'm talking about because this is the addition of this value is arrived by summing all these values. So that means it will now become the kilowatt hour per meter square for a day, only one day only. So if you want to know to arrive the energy in the month of January, for entire month of January, then you have to multiply this by 31, 31, because it's a for one day. Similarly, in the month of February, you can this is for one day, this is for March, this is April, like this. So now if you want to know the average value, that's why in the first slide, when the potential is there, these values are varying. If I say every day, it will be different, or average for a year, it will be different. So that is the things you have to consider. So I think if at that particular location, I want to know that what is the order of the solar energy at Roorkee. So what I have to do, I have to add this value, which will represent 12 days. So that means average will be, if I sum of these value and then divide by 12, so I can arrive a value, average value. Of course, it's average value for a day, because most of the system most of the systems of solar energy are sized or designed on daily basis. So that means at Roorkee, this value I think this while designing the system, I'll use that value. So please remember that. Suppose I can say six it is 6.2 kilowatt hour per meter square. I will be using this value when we design. So please remember that. It's just I'm just assuming. Then there's one more thing. One more thing is there. That means this is also it's very important to understand, because our this surface, Earth surface is not flat. It is not flat. It is like this, sir. So that means if the sun position is this, with respect to, if I am here at a particular time and my receiving surface is horizontally capped, so that means the solar radiation falling at exactly 90 degree or nearby 90 degree. And at that time only, if some other person of different location on the Earth surface, he keep his receiving surface say like this. I think there should not be any confusion कि भी नीचे नीचे सरक जाएगा, ऐसा तो नहीं है. With respect to sun, I am talking about. So at that time, what will happen? The solar radiation will reach to his surface like this. So now I think you can understand that the solar radiation at that particular time, I'll have the more solar radiation than this. So how? Because energy from the sun is coming in with the constant value. But when I receive, I have the advantage. But this person is not having advantage, because the solar radiation is not falling on his received surface at the 90 degree. So that means I cannot ask the sun, I cannot pray the sun that please come over here and give him the solar radiation now. But I have the option. What option? I can tilt this receiving surface. I can tilt with receiving surface. So that my condition, my this situation will be the similar. So this way, you will find that in the practice or in the field, that all the solar energy systems, they are not installed just horizontally. They are installed some inclination. So that is the reason. And this inclination I'm telling you, because I have to cover this गागर में सागर भरना है मुझे, 1.5 घंटे में सब करना है. So I'm telling you that this tilt angle you can have equal to nearby the latitude of this location, or plus minus 10 to 15 degree. So summer and winter. So in at Roorkee, I'm talking about all the systems are, because 30 degrees is the latitude. So I am installing all the systems about 40 degree, 40 to 5, 40 degree angle. So this is the things. So let me finish this, then we'll ask the question. I'll request you to ask the question. So that means there is a procedure. So again, it will take 2-3 hours if I explain that. But I'm telling you that what is the requirement? Requirement is that because the solar radiation which we discuss in the table, those are measured on horizontal plane. But exactly the accurate value or the exact value to the input as an input to my system will be inclined. So I have to convert that. So that means this is the. Let me tell you that suppose this is the. I put this my system at this angle to the Earth surface. So what will happen? This is the diffuse radiation. One more component will be falling on that. because now it is inclined. So that means the same solar radiation will be falling on the nearby body, and if it has the reflectivity, so some solar radiation may fall. So now I have to consider these. That means now I can say that I have to consider beam radiation, I consider diffuse radiation, I have to consider reflective solar radiation also. This also I consider. That will be there. But I don't have this value on inclined. So that means there I have to introduce the tilt factor. That will be total solar radiations will be HB, RB plus HD, RD plus HR, RR. This HB you have measured, HD you have measured, HR can be find out that total into reflectivity of that. So that, but this RB, RD, RR, these are the tilt factor. Sorry, because I'm keeping the time in my mind. Otherwise, I could have tell you the more thing about this. But anyway, I had to complete this exercise. So now I tell you that because the final the input I have to consider in this HB, RB, HD, RD, and HRRR. So these values are there. So that these value I have to determine, and this is nothing but the various expression there. RB is the defined. I think so this solar radiation beam radiations can be defined accurately because this is directly coming to me without any change, without changing any direction. So that means I know the position of sun with respect to earth with my locations every time, every day, or every day or every hours, or every or a particular place. So that means it will depend upon the what at what are where you are want to work, what time the day of the year, and what time of the day, and the tilt angle. So these are the factors we have to consider to determine this. So here this angle is the omega, I call this, and it is nothing but it is every hours is 15-degree difference is there. At noon is 0, 11 a.m. is plus 15, and 10 a.m. is 30-degree, like this, plus 30-degree, and this 9 plus 45-degree, like this. At 1 p.m. it is the omega value is minus 15, 2 p.m. it will be minus 30-degree, like this. So that means whenever you want to take the value of omega in the expression I'm just discussing, so you can take. So time of the day, sorry, this I'm talking about the time of the day, this hour. And tilt angle, as I told you, it could be if the latitude is 5 degree, so then this latitude 5 degree, so that can be taken as sorry, this will be tilt angle. And now the only thing is that it's a time of the year, that which day you are working. So in this, for you have to find out the declination. So I think these steps, in brief, I can say you can use, and all the expressions are self-explanatory. So first you can find out the declination. Declination will depend on the which day of the year. Suppose I want to determine this declination on January 1st, so n value will be 1. And if I want to determine this declination on 31st January, its value will be 31. And 15th February, it will be 31 plus 40, this 15. So like this, you can say, if you want to determine the December 31st, so I think you know that this value will be 365 or 365. So that way, put that value, it will be given directly in degree. So now this RB you can find out. Phi is the latitude, S is the tilt angle, declination you have found, that which day you have found omega, at what time you are doing. So all this value will be RB. And diffuse radiation tilt factor will depend only the tilt angle. So that this will be 1 plus cos. These are the derived terms. I think in the actual class I derived this, but here I cannot derive, but you can use that. And similarly for the solar radiations for the tilt factor for reflection, we have this 1 minus cos theta. So that is finally this will be the input. This input we have to consider to design our system. So now I have talked about the solar radiation's potential, how you can estimate in a very fast track. I don't know that it's there, but at least I just touch upon that this is the exercise you need to at least to know the what is the input, what is the solar radiation, or what is how much resources available to you, which will be considered, what value you have to consider as the input to the system which you are going to design to fulfill your requirement. So I think just 2-3 minutes. You have quick questions. Or query. I can answer. I'll answer that for you. Hello, anybody? Any question?
Yes, yes, please. Yes, please. Dr. Saini, I am audible to you, sir?
Yes, yes, very well.
Okay. Okay. I am Professor Goyal in chemistry in State Engineering College, Pori Garhwal.
Oh, yes, great.
Okay, that's how I got some information related to the solar system, but there are some queries I wanted to discuss with you. Although you haven't touched most of the part, which is very much important because of the time constant. But okay, one important thing, what is the time duration in a day in which we can use the solar energy?
I think it depends upon the sunset.
Considering all the factors, I am taking the ideal condition. Say I am saying the sun starts from at 7 and it ends to the at 5 p.m. Then
Yes.
what is the best duration in which we can utilize the solar radiation?
No, I don't say that you utilize the solar energy on a particular time. I can say that you estimate the how much solar energy is falling on the Earth's surface for entire day, for the entire duration in a day. You have to collect that, and I think it's okay. I think
You have already discussed that thing, sir. You have already discussed.
yeah.
Yeah.
This table is that. So I'll
Yes.
give you that. I'll design my system on this
Yes,
value.
yes. I take it out, sir. I take it out.
Yes. Okay.
Okay, this is another important question. Can we utilize the solar energy for making the biofuels, sorry, especially fuel in hydrogen?
That is a yeah. That is the process. That is the
Yeah.
process.
So, are you
So
working in that field in fuel cells, hydrogen fuel cells?
सर मेरे को 3 घंटे अलाउ करा दीजिए.
Oh, so that's a fuel cell. I will directly contact you directly.
Yes, please you can put the question directly.
I
अभी
will take it from you. So nice of you.
अभी अभी ऑर्गेनाइजर्स को बोल दीजिए कि मैं
हाँ.
6 घंटे बोलता रहूंगा, कोई दिक्कत नहीं है.
We can make a separate discussion over this, sir. That's okay.
I always enjoy that if somebody asks the questions and I clarify each and everything, all the
Yes, yes,
confusion.
yes, sir.
But
Means,
I always I'm keeping my eyes on the time. So
yeah.
that is वो तो ये लोग तो
I
organization
can understand, sir. That I can understand. Actually, what is the problem? In pandemic, we are not be able to make the one man-to-man discussion. That is the problem. Otherwise, I can ask too many questions. I have too many things to discuss with you.
even I love it. I love it. But the thing is that
There are lots of solar panels now you presently using either thermal or maybe the photovoltaic.
yes.
There is another one, chili saltpeter.
Pardon?
Chili saltpeter, the potassium nitrate they are using in solar energy to restore the energy in place of putting the energy in batteries or maybe as a hot water.
Yes.
Having any idea related to it, sir? Because I'm a man of chemistry, that's why I'm asking this question.
No. I'll say that if you really want to utilize the solar energy, and I can say that the mainly drawback with solar energy is storage.
Yes, yes, that's why I'm asking, sir.
So that the storage technology are different, because if you generate electricity, so there's the only I think direct storage is batteries only. So that batteries has some
Someone asked me this question. I was giving one lecture on the green chemistry. Then I have realized some of the videos and some of the material on solar. Someone asked me about it, that what you will do if the sun is not available, the storage.
That's why there's that, because even the solar thermal power plant, I think solar thermal power plant, they are generating electricity. And the advantage of this, if you compare the PV plant and the solar thermal power plant, so the biggest advantage of solar thermal plant is the storage only.
Yes.
Because that heat energy is stored in the sensible type or different type. There's another area of storage,
Yes,
thermal
yes.
storage. So all the thermal storage.
I have the idea about that particular, sir.
Yes,
We
yes.
can make a discussion, separate discussion with you.
Oh, sure, sure, sure.
Sure, sir.
I think
Nice
I
of you.
think this title is in general, or it could have been a very specific. अभी मुझे बहुत प्रॉब्लम होगा कि कैसे मैं इसे एंड करूं, क्योंकि
Yes,
मुझे बहुत
yes,
सारे.
that is the main issue, sir, because you just have started the material. But
Yes.
it required at
Yeah.
least 6 to 7 hours to explain all the things.
So quickly, I'm just going through that all the things. So I
So,
just now that, as I told you in the beginning,
yeah,
that
please,
this
please be
is the
continue,
base.
sir.
Pardon?
Please be continue, sir. I have no more questions.
Yeah. Please.
Thanks a lot, sir.
Yeah, please mute that. Okay.
Sure.
So now that's, I think, as I told you, that this is the beauty with the solar energy. That means there are two different routes. That is solar photovoltaic, directly I'm talking about, and solar thermal. Even this through this route, this solar thermal, I can generate the electricity, but that is a thermal route. That is a thermal plant, like the coal-based thermal plant. Because it's a, so that means why I'm talking about that in the very beginning, you have to decide whether you need electricity or you need thermal energy. In solar energy, I'm talking about. If you are talking about the hydro, it's okay, because if you need, you have to follow the only one route, that from hydro you can generate the electricity only. Then after you can convert thermal. But in solar energy, that means you have to decide in the very beginning that whether you go to solar thermal or solar photovoltaic electricity or thermal, because the system is entirely different. So the system which is used for this electricity generator is not either PV cell or the photovoltaic system. While in the solar thermal route, it is known as a solar collector. And again, the solar collector again will be different type. For high temperature, if you need the, say, about 200 degree or 100 degree centigrade or few thousand degree centigrade, then you have to use this technology. And for low temperature, say up to 100 degree centigrade, you go around 100 degree centigrade, you go the flat type. And there's again the flat plate type. If you need, if the heat transfer fluid is liquid, so it will be known like our hot water systems are. This is the type of hot water system. And if you are using the air or the gas, so that means they are solar air. So in most of the cases, when you want to dry the process, you need the drying process, then the air heaters will, this solar air it will be. So this is the things here. I'm very quickly I'm talking about. So in that case, that means this is the process. So main component here, this component is known as the solar cell or solar module. So this solar modules is again it's not the property of the material. It's not the property of solar radiation. It's not the property of this combination. What we have to do, that means we have to create some, you have to modify the material property, then only you will make the, so that means if I can say this is the base material, say silicon material, and if the solar radiation is falling on this, so the solar radiation will have some energy. So you know that this material have the atoms, and around this the electrons are there. So these electrons, what happened, that get the that the extra energy from the photon, it will it will be dislodged. So that dislodged electrons you have to take out from the material and then to the battery or to your load, and then that extra energy will be transferred to the battery, and then again you have to send these electrons there. So that's the process. So that means how you can get these electrons at the surface, you have to create the p-n junction. That is the electronics part I'm talking about. So that is the I think it looks a magic. It looks a magic that how the electricity is generated when a material is exposed in the sunshine. So it is the, that means a special material, that is the semiconducting material, which is easily to dislodge the electrons from their their bond. So that is the property. And the second thing is that when these electrons get the extra energy from the sun, photons, then you have to provide some provision by creating PN junction. The PN junction is the positive negative charge field. So it will thrown away out of the material and then you can use. I think this is the technology. And so this is basically we need to design. Design means these are the readily available in the market, and to size the system, I want to know that how many modules I need to fulfill my requirement. And similarly, this the procedure to this route is that is okay. I tell you here that is simple. First, I just already explained you this how we can get the electricity from the PV module. That because आप समझते होंगे कि बहुत सारे शीशे लगे हुए होते हैं. That is the module. I call this a module, and this module have number of cells connected in series, and then the sunshine will fall on this. So that means electricity is generated. So this is the basic device of the system. Read. And what you have to do finally, basically, if a typical system, I can say I want to power my house or power my area through this PV system. So these are the basic components, and the main component is this PV module. Directly its electricity, and then it is the power conditioning unit. That means this module generate electricity in DC direct current, but my requirement may be AC. So then I need the this inverter which convert AC to DC. So that has to go to my demand. Sometimes if I don't have demand, so what I have to do? I can store that energy as you are talking about. That means suppose night time I want to electricity, so that means that time I cannot use directly this. That time I have to store that electricity in battery, and then during daytime I store that, and during night time then this battery will be used to light by for lighting purpose. Similarly, there if some configurations are there nowadays. Rooftop, you might have heard about the rooftop system. The rooftop system is they also they power your house, but simultaneously those are connected to the grid also. So that means in that case what you have, that means if you don't have sun, you can draw the power from the grid, from the normal uh, grid line, or if you have the extra energy, that will go to the grid. So that means there is a provision here. State government, even sometimes the electricity generated by your system will be costly. That you will get the more price, and when you draw the electricity from the this grid, it will be less to promote this, to give the incentive. That is the only thing. Now I think in 5 minutes I want to tell you that how you will size the system, how you will fill your your suppose it's okay what I'm talking about. Just have the problem in your mind. So I just give the example. That means suppose in the area of fuel. I think now you connect this subject. That means you want to produce the biofuel. You want to produce the biofuel from the biomass, and you need certain amount of electricity to run your processing device. You need some electricity. So that electricity can be obtained if you are not connected with the grid. If it is you want to power your device by solar energy, so how much solar energy you need and what will be the size of the system, PV system, that I'm going to tell you. I think it's okay. Are you ready to listen that? Hello?
Yes, sir. Yes, please,
Yes.
please.
Yeah, I think it will be better. You will have the interest. Otherwise, आप तो सो जाओगे अगर मैं कुछ बोलता गया आगे.
You please continue. We are noting everything.
Yes. So that is a very simple example. It's a thumb rule, like but it's a perfect example I'm giving. Just have your requirement, and that requirement, your energy requirement, please estimate that. please convert that per day basis. That means you have, suppose you have some data that in 1 month or in a year, that much kilowatt hour you need. But I think to design the PV system, you please estimate on the daily basis. You divide that. So that means finally, I think your requirements should be that. That's why I'm talking about the load estimate. So I can say, so some value you have to estimate for your demand, that will be in watt hour per day. I think you got it. Daily basis. As I told you, that all the PV systems are designed on daily basis. So I think you have taken the average that every day I need for my process this much energy per day. Is okay? Any confusion in there? No.
No.
Then yeah. Then I'm just telling. I told you that time when I discussed the potential. So that means that value also you have to arrive. What value you have arrived? That I told you the 6.2 kilowatt hour per meter square per day. That is also you have to estimate for your area. So suppose that value, again I'm repeating here. I think can you recall that value? Please tell me.
For solar energy, sir?
Yeah, that's estimation of solar installation.
Yes, it is
Yeah,
47 kilowatt power.
yeah. I just estimated I estimated the yearly base. I taken the average for a year by
Yes,
adding all this.
1353.
Yeah, I think that I'm just taking this example. Just suppose that is 2.6.2 kilowatt hour per meter square. It's an example I'm taking per day. You got it? Right. So now this is your per day requirement, and this is the available. This
Okay.
is per meter square. I think. Okay. So
Hmm.
now I want to size the system. Very easy. I think if you'll be able to do this. So now the sizing of the system, you are not going to produce the module. What you have to do, you are going to buy the number of modules from the market. I think you
Right.
got it. Yeah.
Right. Right.
So that means you go to the market and select any standard size, standard rating module. So suppose I can say that you select a module whose rating is 230 W watt per meter. Sorry, watt. 230 watt. That's the rating. I think जब आप कोई इंजन लेने जाओगे या कोई सिस्टम लेने जाओगे, बोलोगे ना जनरेटर लेने जाओगे, भाई 5 किलोवाट का दो, 2 किलोवाट का दो. हाँ. So similarly, you are going to select a module from the market that is also in watt or kilowatt. So it means 230 watt. But I think whenever you write the rating of a module, it has to be with P. This is don't write in even in the class. Don't write the rating of the module without P. This P is the peak. Peak. What is the meaning peak? It is not the maximum, because this rating which you have specified, you have taken, this is given under a standard value of solar radiation. The
Right.
manufacturer tested this and it produced 230 watt when solar radiation was 1000 watt per meter square. Okay.
Okay.
So now problem is that I will not, it is not possible to me that to estimate that how much energy it will deliver if I put under sunshine for an entire day. Can you estimate? No, I don't estimate, because I'm talking about this output is directly proportionate to this. I think this is there. Nobody will deny this. If the 1000 watt per meter square value is of solar radiation is there, so its value will be, its output will be 230 watt. It's okay. If the solar radiation is say 100 watt per meter square in the morning, as you told that which value I should take. Okay. So suppose that 100 watt per meter square. So that means it will deliver only 300 watt only. If it is 500 watt per meter square, it will deliver how much? 115 this 115 watt only. So that means it is, how I can say, because the whole day solar radiation will be varying like this. will be like this. So I don't know how much it will deliver. So there is a method. I think this method, you please try to understand, then things will be over. So there is the method. That means this value you have, this value of solar, this is the energy you have collected whole day. Huh? So I just play with this term. How I can play this term? I just write 6.2 hours into 1000 watt per meter square. Can I write this? This unit in a day, can I write like this? What is this? It's a watt hour per meter square. So I can say that if I convert the total energy equivalent to the peak hours, I can say that how, pardon? Hello? So I can say,
दिक्कत क्या होगी ना
so that,
इसको
huh?
एक आंसर से ले जाऊंगा मैं पहुंचूंगा सर यूनिवर्सिटी बंद मिलेगी माली बस इतनी
क्वेश्चन पूछ रहे हैं साहब कोई?
Please continue.
Okay, okay. So I think now you can say that means I can convert this value corresponding to peak hours. Peak hours means when I get this energy, when I draw this energy in the in 1000 watt per meter square, so I can have only 6.2 hours. So that means you multiply your rating, this peak power of the module. That means a module will deliver how much? A total, the module power output will be, each module will be 6.2 into 230. That means this will be watt hour per day, of course. You got it? Clear? So now your problem is solved. You have this much, your requirement is this, and your one system, one module will deliver this. So that means total number of modules you can find out directly. I think if you follow this method, so I have the
सर आई गॉट माई आंसर जो मैं पूछ रहा था आपसे.
पूछिए सब, पूछिए.
Sir, I am saying I got my answer. At what time of the day we will get the maximum? This is your answer, sir.
It's okay. I think you are.
Yes, now it's clear to me. Now it's clear to me.
So now it's a simple mathematics. Whatever I have discussed, I think this is given in this table. You can have, because in a day how much energy you need, and one module will produce how many. So you can find out the number of modules, and that these modules you buy and install that. That is there. And if you have some electrical background or something about the electrical, so then you can have the number of modules in parallel and series. That is there when you connect there. I think time will not allow to me. So then next is the system is known as the collector. For this, I'm talking about when you need the thermal energy. So the system is known as the collector. And as I told you that this flat plate collector is for, it has the limitation that up to 100 degrees centigrade you can get the heat, but this you can get the few thousand degrees centigrade. So that means depending upon your requirement, you have this, and for this. So various components are just, I think I tell you that the simple flat plate collector is nothing but you have the transparent cover, and then below that we have the absorbing plate, and below that we have the water, the fluid flowing passage. Ultimately, what happens when the solar radiation is falling on this transparent cover, it gets absorbed on the hot plate or the plates, the metallic plate. Then this heat is generated. It has to be transported by allowing the fluid flow in its contact. So that fluid will take the heat, and then you can use that. This is a simple, and nowadays evacuated tube, and there's so many technologies are there, but in the simplest way I'm telling you. But you can say that if you are going to use the flat plate solar collector, so you will not have the temperature more than 100 degrees centigrade. There's the limitations of that. And the advantage is with this, that means it can it can collect both the solar radiation, diffuse and beam radiation also. So now we have, based on this, we have the this drying system. That means you can circulate the from the collector, you can circulate the air and you can dry. I think this is again, the only thing is you have to collect the things, and sometimes you need the storage also. This B is the storage. As you asked me that what is there, that means if the solar radiations in the daytime available and it's a solar collector, that means that heat, because the fluid is flowing, so that fluid is flowing through the collector, it will become hot, and then it will transfer to it can be water, or it can be some solid pebbles or packed bed, so that heat will be transferred to that media could be water. And then when you want to heat in the daytime, then you take that heat by just flowing the cool air. That cool air will take the heat from the storage, because now there's no sunshine here. It will be closed that time. So that means that heat can be used. So that is the storage integration of storage sometimes. Similarly, this is the simple that hot water system you experience in your rooftop. It's very, so that means, but we don't have this pump. It is a thermocyclic effect. That means when the hot water is lighter in weight, so that it will flow. We don't have the small system I'm talking about. And if you have the large system, then you have to have the pump. So then next is this when you want to achieve the high temperature. So that means you have to, because we consider the solar energy is the low grade energy. It is we have to concentrate. We can concentrate it. So that means what is the concentrated type? That means what happened, that whatever energy you collect over a larger area, and then can be reflected back over a smaller area. So that energy over this area, which is collected from the sun, now it is focused over a smaller area, so that you can achieve the high temperature, very high temperature. जैसे schools में हमने कागज जलाए थे physics lab में, lens, that is nothing but that is concentrating type things. That means the solar radiation falling on the lens, and then it is concentrated over a point, and that point becomes so hot that it will fire the papers. So that is the same concept I'm trying to explain in the simplest way, in the layman language. So in that case, the temperature, the order of the temperature will depend upon a factor which is known as the concentration ratio. That the CR, I call this is CR. The CR, this is a concentration ratio. I think this is very important in this technology, concentration ratio. That is nothing but is the ratio of this, the frontal area. That means at what area solar radiation falling. And then after reflection, what is the area? This is very small area. If this is very big area and this is very small area, you will have the concentration very high, and you will get the temperature order more. That's very high order. So in that case, this is nothing but this aperture area of the concentrator, and I just write the C, concentrator, and area of the receiver. This is the receiver. So that means depending upon we have different type of combination. So sometimes this simple, this is. Then accordingly, if I have the plane reflector and plane receiver, so the concentration ratio can be achieved up to 4. You want to have more, so that means I think this is nothing but that. Suppose this is the receiver and this is the concentrator. What will happen? That means if the solar radiation falling on the plane surface, and it will be reflected on plane surface. So this is the first type I'm talking about. So in this type of system, I can have only concentration up to 4. The another type is the conical and cylindrical. That means if the receiver is of a tube, in the form of the tube, and the concentrator is plane. I think this is the conical. I can say this is conical means the flat plate is conical. So that means this is the thing. This is reflector, and this is the concentrator. This is receiver. So that means under this case you can have the up to 10. And it's the parabolic. Parabolic trough is, I think this, you know, that is a parabolic trough. This is a curved thing, and at the focal length, you have to receiver. This is a cylindrical. So in that case, you can have this is used for the high temperature. That is, solar thermal plants are used. Most of the thermal plants based on this. And if you have a very high temperature, so concentration may be enhanced up to 10,000. That is the paraboloidal. That is a dish like this antenna you might have seen. And this receiver will be a spherical. It's not the cylindrical, it's a spherical. So that means in that case, you can you can have very high temperature, 2,000, 3,000, even sometimes 5,000 degrees centigrade also to this system. So that means depending on your requirement, you can have this accordingly. This is the things. This is the parabolic. This paraboloidal. I told you that this is the disk and this is the receiver. And here this parabolic trough and this receiver. This is the tube, and this is the central type. This is also point type. So that means you have number of mirrors around this chimney, or you can say tower. So that means the reflected solar radiation will reach over this point. So I think, and nowadays, very simple mechanism is a Fresnel type. That is also, that means reflector are there and it will be directed over a tube. So through this tube, there is a fluid is flowing. So that means these are the technology, but still in India, we are not developing the solar thermal. We are going for the PV only, because PV में क्या है कि वो जो मैंने बताया, शीशे खरीदो, लगाओ, बिजली बनाओ. But I think we must follow this. We must start doing. We must follow this route also simultaneously, because in developed countries, say that means Spain or USA, I'm talking about. So even Spain is totally based on the solar energy. So all maximum energy requirement they fulfilling by solar energy, but they have maintained some ratio, some say 60-70% through PV and 30-40% from thermal. But in India, if you are talking about the 100 gigawatt target 2030, so 2025, or so mostly we are just developing the PV system only. But after some times we'll face the problem. I cannot say that what problem will be there, but definitely we are going to face some problem if we are not maintaining this route. We have to maintain this route also. Of course, it has some disadvantage, but lot of many advantages it has, which we are not, which we are ignoring because of the just to get the quick things to meet the target. Anyway, so this is now the fuel. This I think 5 minutes I just take that how we can integrate, how we can use the solar energy as fuel. So in that case, there's a R&D project which we are doing on this. So it is a practically based. That means you know that a lot of this pine trees are there in Uttarakhand. We took this data from the Uttarakhand only. So there's a product which is known as the resin, जिसको गोंद कहते हैं, and it is a hundreds of ton, and even you guys can say thousands of ton. It is produced. It's available. And what they do, I think in early days, traditionally, what they have the bhatti like. गाँव में जैसे I don't say that the Swarab ki bhatti, but it looks like a Swarab ki bhatti. They had traditionally they processed that to make the turpentine oil. Actually, the process requires the heating in two stages. At one stage is because it's a solid. Resin is a solid material. So that means at one stage they want to heat that about 80 degrees centigrade. So then it will melt, and then after the melting this solid, then they try to remove this some dirt, and after that again in the second stage it is heated about 280 degrees centigrade, and then when this it will be evaporated at 280 degrees centigrade. So that evaporation, they have the condensing process. So after condensation, that you will get the liquid. That liquid is the turpentine oil, and the remaining things is known as the rosin. This is also a product which can be utilized to make the toys, and in paints also this is used. So that this process they use that. So I tell you that what we can do as a R&D project, and you can motivate your students also, that they should visit, they should go to the field, and then try to find out the problems of the peoples, and then see that there's some technology still they are using which is not efficient. So that means the students take the project from. Hello. Hello. Okay. So that means this is the. I'm telling you that we just collect the data from the field in the state of Uttarakhand, and then we found that this is the their traditional method they are applying. So this is the first stage. This, and they use this biomass. Biomass means the जो लकड़ी वहाँ पे the फ्यूल वुड, जैसे वुड फ्यूल जो यूज जो लकड़ी मिलती थी तब तो काफी वहां पे कोई प्रॉब्लम नहीं था वुड का. तो देन दे यूज टू दैट, दे यूज एज ए फ्यूल, locally available fuel. So in that case, they did that, but now I think it's very difficult to get the wood in the hilly area. So that means now all the bhattis are, or the processing units are defect, and the peoples are in trouble. That means they are not generating income, because the, the firewood is not available there. If they transport from there, it will not be economical. I think this is the conditions we found, that this is the conditions of that thing. So in that case, what we had, what we, because they say thermal route, the thermal process they need. So there is a possibility to achieve this 280 degrees centigrade just with a concentrating solar collector. So we just studied and then modified their process so that it should be efficient. It should be, that process should be efficient. So accordingly, what we did, we just design a concentrating solar collector by estimating the requirement. So that requirement of heat will be fulfilled by this. But now the problem is that this again the professor, he asked the question that at what solar radiation we should. Again, we don't know that how much it will be available. So that means if it is not available for few days or for that particular time, so that means our unit should not be stopped. So what we did, we integrated a improved chula, a improved stove, which is I think there's 15 years, 20 years, there was a big program with MNRE to improve the chula. And now I think because of the LPG, everybody is getting LPG. So chula ek taraf pade, like technology is still there. So that what we did, we adopted that technology. And if some energy, some deficit of energy we need, we can use still some wood also. And that, even that I can say there's a biomass. This I'm telling you here because the time constraints is there. So that means you know that there's a pine needles are there. Pine needles are there. So wood will not be there, but pine needles are there. So we have developed a machine, a efficient machine, which make the briquettes from the pine needles. I think the pine needle technology you have found in the literature, they need some bounding materials or they need some process. But I think we have the system we have developed. Simply you put the raw pine needles and you will get the compressed briquettes. So those briquettes can be used here. Now, still the study is going on. So finally, we are going to transfer this energy to so many industries. They have approached to us to get this technology. But after some times when we'll do complete analysis, energy analysis, then we will transfer this. So that is the things in a short period I'm talking about. This is the experimental setup we did, and I think it's a very fantastic thing. Even I didn't believe that the tarpin oil will be made like this. The 2 more minutes I am taking that because this solar power at IIT Roorkee. So the same procedure you can adopt this, because what we did, uh, 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 this is the campus, our campus. So we recommended, how we recommended, that means we give the project to our students with some faculty, and they just carried out, they have audited the energy consumption of the campus, and then based on that, we decided that how much energy will be required in the form of electricity, and how much need for heating and for cooking. So accordingly, then we have decided, we have optimized. It's not that we are replacing the entire energy through solar energy, but at least based on the cost optimizations, we have decided. And then the three type of system we have recommended. One is the solar PV, which is directly connected to the local grid, our grid, the campus grid. And the area of the this is the steam cooking, because we have 9 messes in our campus. So that means cooking is, we need the high temperature solar collector, and then which is concentrating type. I think whatever technology I have discussed, so all are demonstrated, means not demonstrated, we are using that, we have installed that, the concentrate type solar collector, and this is for flat plate solar collector, that's a solar water heating, and this is the PV system. So these are the, I think this slides I'll be going to, I'm going to share this, so you can see that, so that quickly I can say. So the total 1.8 megawatt, that's again peak, 1.8 megawatt. What PV? And the and water heating, 4 lakhs, because the hot water system, they are represent, they are specified by how much liter per day. So that means this we have estimated. And similarly steam cooking also, so that we just estimated that we can save the 5,000 cylinder per year. So that can be saved, that is achieved. I think this is, we have confirmed that we have achieved this by having this system. So that is the things, that means the how we can connect this solar energy in fuel. So this is the way, that means we can either, when you want to produce the fuel, so you can use the solar energy in your processing system, or you can replace the fuel by solar energy direct application. So that is also, we can say that the solar energy is itself a fuel. So this way, I think this is, I'm going to share with you. So timely, I want to, I think this is the system. We identified that all the departments actually, this rooftop of the all the departments we are using to use this, so that ultimately, finally, we got the 1.8 megawatt peak. Okay, and then this is the things. All departments. This is a PV system, and then for this, you can say this, for steam generator, this is the rooftop of the masses building. And I think this the nine, this Azad Bhavan, Ganga Bhavan mess, Rajendra Bhavan. So we have 9 messes, so that this we are using this. And this is the hot water system. As I told you, that this is the capacity is uh, because each modules having 200 liter per day capacity. The temperature rise about 60 degrees centigrade above ambient temperature. So depending upon the requirement, each and every household or the building, the residence building, we have the hot water system. So this is the things we have carried out the study, and still we are monitoring. And the beauty with this is that means we have given the 25 years maintenance contract in the order itself. So that means the company who has installed this system, they are maintaining it. So we are not, we don't care about that, but with some penalty. That means if some losses will, because they have fixed that at least this much energy they have, our system should generate. If it's less because of the poor maintenance, so that means that penalty the company has to pay. These are the hot water system here. You can see that. And thank you very much from my side. And I tried to accommodate so many things in hurriedly, but now if you can have some questions, so I can answer. Thank you from my side.